Hi, this is Javier Encinas. In this video, I'm going to show you how easy it is to design, check, and optimize your calculations in ASDIP Foundation. To do that, I'm going to use one of the verification examples in our website. This example is taken from a textbook, very recognized and well-known. It's Reinforced Concrete Mechanics and Design, 5th edition by Wright and McGregor. This is example 15.4. It shows a combined footing. The example says one column is 24 by 16 inches. The loads 200 kips dead, 150 kips live. The other column is 24 by 24 square, and the loads are 300 dead and 225 live. Distance between columns is 20 feet. Allowable soil pressure is 5,000. So basically what it says is this. We have two columns and a combined footing between them. One column, the exterior columns, is just at the property line, so the footing cannot extend beyond the column face. So this will be taken into account in the program. The interior column doesn't have any problem, so you can extend the footing beyond the column face if necessary. The loads are here, and the column sizes, distance between columns is 20 feet. So let's open ASDIP Foundation. So basically the modeling is here. In the geometry tab, we can model the column to column distance, 20 feet, and basically we are assigning some dimensions to the footing and changing later on what we assumed originally. Same thing with the footing thickness, 40 inches. Columns, this information is given by the example, 16 by 24, 24 by 24. Loads, these are the loads that are given by the example. In dead is 200 and 300, and live is 150 and 225. Materials is the concrete and the steel F'(C) and Fy for footings and for columns. Reinforcement, all the rebars can be modeled here very easily and straightforward for footing and for the columns as well. So let's focus mostly on the output part of the program in this case. So the modeling is very easy and straightforward. We have three ways to see the calculations. One is at a glance. We can see the results just in one screen without scrolling. For example, here we can see that the pressure is exceeded or is very close to the limit, 5,000, and also we have a problem with the one-way shear in the interior column. It's 9% overstress, so we need to take care of that as well. The rest of the parameters or the rest of the checks are passing, no problem. Just at a glance, is very well. We go to the condensed tab. We can see the results in more detail. For example, here we can see the overturning calculations step by step. We know that in this case we don't have a stability problem, so in the footing are also designed here, the exterior footing. So you can see the one-way shear and the punching shear. The controlling combination is also shown here. So all the calculations are shown here and can be followed very, very closely. Transverse, flexural, reverse with a combination that controls also there, and the ratio. The load transfer for the exterior column. All the checkings are here. The bearing strength, the shear friction of the footing. Here is check the minimum area of steel and the development length. So all these checks pass in this case. The same applies for the interior footing, similar to the exterior. So the one-way shear, in this case, we already know that it's overstressed by 9%. If we compare 309 versus 283, so it's overstressed, the one-way and the capacity. The punching shear, the checking is here, all the parameters. The ratio, the punching is 0.41, so it's no problem, it's perfect. This is the combination that is controlling. Excellent. So this is a bending rebars, checking the flexural capacity and the development length ratio of the rebars. No problem at all. The load transfer, similar to the exterior. Here are checking the bearing pressures and capacities on the columns and the footing, shear friction, and the development length, also the minimum steel. So no problem with that. Sliding, no problem with sliding this in this footing. This is the calculation of the longitudinal reinforcement. We know that for a combined footing, the main longitudinal reinforcement occurs at the top. So this is shown here, the top and the bottom. The acting and the strength. So if we compare that, we are okay. These are the ratios. If we need a more detailed set of calculations, we go to the next tab, which is Detailed tab. Same thing, but all the calculations are exposed with the formulas, step by step, and also with reference to the code. So you can follow everything, every single calculation here, step by step, with the formulas exposed. Here's your returning calculations, sliding, uplift. So the stability checking is done there. Here, one-way shear calculation. Here is where we saw that we have a problem with the one-way shear. We will take care of that in a minute. So all the calculations for the one-way shear are shown here with the reference to the ACI code section that applies. Next is the flexural calculations with the controlling combination. First and exterior columns, all the calculations are set up here, including the development length calculations, as you can see here, and checking the minimum, so everything passes. The same applies to the interior column, similar set of calculations. And finally, the longitudinal reinforcement in the X direction, top and bottom. All the calculations are here as well, and bending capacity at the top and at the bottom, and the ratio, so everything is passing. Next is the punching shear calculations with the controlling combinations. All the calculations are here with the reference to the ACI code that applies. And finally, load transfer calculations for both columns, exterior and interior, bearing, shear friction, and the longitudinal development length. Finally, the column calculations. The program checks the capacity of the pedestals or the columns and verifies that complies with the load. Graphically, the program generates these graphs. First, in the bearing tab, you can see the bearing pressures acting on the footing in elevation and in plan view. Here are the shear and the bending diagrams. Typical shapes for a combined footing. We see the maximum moment, negative of course, meaning that the main reinforcement occurs at the top, as we can see in this view, top reinforcement. And here are the columns design. So the program designs the columns or the pedestal for the, these points represent the actual loads, and the interaction diagram is the capacity of the column. So in this case, both columns, which are different sections, both pass. So you can see how easy it is to check, analyze, optimize your design. For example, if we want to avoid the problem of let's go to at a glance. Well, first of all, we have a problem here with bearing capacity. Just a little bit is over stress. So let's modify here. For example, instead of 5, this occurs at the exterior, meaning that we need to increase the interior a little bit. Let's put 4.7 maybe. Yes, so that passes already, okay? So with this little change here, we make sure that it passed the problem. We still have a problem with the one-way shear. Shear problem, well, we have a couple of alternatives. We can increase the thickness of the footing, and of course that will alleviate a little bit the problem. We have now 40 inches thick. Let's try, say, it's only 9%, so let's see, maybe 42 inches instead of 40. It's borderline, it's 1, okay, maybe 44 maybe. Yeah, 92%. So we have here a problem. Yeah, because we increase the thickness, so the minimum steel area of the footing suffered because more concrete. So we need to increase the rebars as well. To do that, we go here. So this in particular is the in the Z direction. Okay, maybe we can put these are the columns, the footing. Maybe we can increase the number of rebars, maybe 7. 7. Okay, yeah, that passed. And we have the same problem here. Yeah, the idea is to change whatever we have to and optimize the design. Move here, move there, change a little bit, tweak here and there, and get an optimum design. When we are completely satisfied with our design, we just proceed to print out. This is a preview for the condensed report. Let's check it out. We are generating the condensed report, which is like this. You can print out this, show it to your plan checker. It's a very nice pre-formatted report. The same applies for the detailed report. Let's go to print out, or let's go to print preview, the detailed report. Okay. Yeah, nice. We can see all them together. Okay, these are all the pages of the report. So very well presented. So this basically show you how easy it is to check the calculations, obtain results, and manipulate the input to modify a little bit here and there to optimize the design. If we know that something is a little bit overstressed, so we go back and modify whatever we have to obtain an optimum design. It's very easy, very straightforward. This is the idea behind our software as it was conceived with that in mind, to be in control of your design and have all the tools at your hands to modify whatever you have to obtain an optimum design. So thank you very much for your attention, and we'll see you in the next video.